This is CPM Calculus, Chapter 3, number 61. So here we're asked to sketch a graph of a function that has the properties listed below. Describe anything special about this function. Okay, so let's go ahead and put our x and our y axis. X-axis, y-axis, right? The limit as x approaches negative infinity of f of x is equal to 4. So let's go ahead and count up to, so this is 4 here, right? And we know that all the way as we go approaching negative infinity, we're going to either be there or maybe we'll be up here, right? Okay, so something around 4. F of 1 is equal to negative 1. So at 1, we know that the output is going to be negative 1. Right? So let me just put a few marks here. Okay? And f of negative x is equal to negative f of x. Okay? So f of negative x is equal to negative f of x. Well, that's just the definition of an odd function, right? So that's what that's saying is, well, f of 1 is equal to negative 1, right? Well, f of negative 1 has to equal to positive 1 then, right? Negative of negative 1. So f of negative 1 is positive 1. And in fact, what we remember about an odd function is we have a rotate 360 degrees symmetry. Okay. So what this allows me to do is I can go ahead and connect these, right? I can do this. But then now once I'm on this side, it has to be, because of this, we know that it's odd, it has to have symmetry. So that means as we go all the way to positive infinity, we're going to have that same behavior where there's the limit as x approaches positive infinity, right, of our function is negative 4. So here, right, you have a horizontal asymptote at 4. Also at negative 4, f of 1 is equal to negative 1. And this is odd function, right? So here's one example. Let's just do a quick example of another one. We know that this point has to be defined as well as this one, because this one has to be defined and this one means it's odd, so it has to have this symmetry, right? So our function can also look like this even. And here at negative 1 we could have an open dot, right? And then it could keep going up to infinity. Well, if that was the case, then it would have to have symmetry here, would look like this, right? Open dot. And we would still have the limit as x approaches negative infinity is 4, positive infinity is negative 4. Still have the the horizontal, what am I saying? The odd symmetry, right? And so green works, so does the red function. Remember, this point is defined in red as well. Alright, so these are just two quick examples that have these 3 properties. Alright, this ends CPM Calculus Chapter 3, number 61.